Yeah. All
Okay,
right.
let
I
me
picked up the
introduce you
mic.
then. Okay, I'll introduce you and then you can go for it. Well, welcome everybody to our DEF CON Groups VR Event Halloween edition. I'm X-Ray, your host from DC 404. And with us now is JBO. He's going to talk about the anatomy of a UAC, which is the Windows User Account Control bypass for that function. Ever since Windows Vista, UAC has been another security obstacle for analysts and attackers alike. In this talk, JBO will explain how UAC bypasses work, how to search for new ones, and how to detect them in the wild. Jonathan Barr, or JBO, is the Microsoft Defender Research Architect for cross-platform, focusing on Mac OS, Linux, Android, and iOS research. Jonathan has rich offensive security research on various platforms architectures, as well as a combination of defensive skills and threat research. So without any further ado, take it away, JBO.
Rock and roll. Thank you. Thank you for attending. And next slide, please, because this is just, yeah, thank you. So a bit about myself. I already got the intro, but Baror is my last name. It has 2 words in it, which is kind of weird. JBO for short. That's my Twitter handle, and I do a lot of stuff. Like I mostly at this point in time in my career move between Linux, Mac OS, iOS, and Android, and Chrome OS, which is pretty funny. But I still do Windows once in a while, and as this talk kind of shows, this is going to be a Windows talk. And it's pretty funny because I do work in Microsoft. So I mean, one thing to note here is that I'm going to say here is like usually my own opinion and not really like I'm not representing Microsoft in this talk. So please do keep that in mind. And yeah, I'm also a husband, a father, and a cat lover. Probably in this particular order. Next slide, please. Yeah, this is how a UAC how a UAC window look like. Most of you probably have seen that once in a while. And I want to talk about UAC bypasses in this talk, and basically what UAC is and how it's implemented, or bits and pieces of it. And then basically we could continue to see some nifty UAC bypasses and talk about how these things are being handled, both from an engineering perspective as well as from an attacker and defensive perspective. So let's continue. Next slide, please. So UAC, if you weren't aware, is user account control, or it's also user access control. It kind of depends on who you ask. And what really happened before Windows Vista, which was a long time ago in a galaxy far away, was basically if you were an admin, you would do anything, right? You would be omnipotent. And then 2 things really happened. One of them happened, I think, in XPS SP3, but I'm not sure, which basically kind of said that in order to load drivers, you have to have a signed driver. So that's kind of like a security boundary that is well respected and treated well by Microsoft. And the other one was UAC. The idea behind UAC is that most programs still require, because of historical reasons, most programs still require to be run under the administrator account. And that's kind of problematic. Imagine on a Linux system, it's unthinkable that people would run everything as root. That's what happens on Windows any day. And in order to combat that, what Microsoft have done on Windows Vista was basically to introduce UAC, which splits the admin token into 2 parts. One of them is called an elevated token, and the other one is like normal token. And using the higher part of the token is called, that particular part is called an elevation. And the idea was that there are certain operations that are just allowed, only elevated half token can do. And that's basically the entire idea. for non-admin users, UAC over the shoulder elevation, but it's not that. It's like we won't talk about that too much. And how is it really implemented, like under the hood? So all secureable objects in Windows, the things that you can put access control lists on, have another thing called a SACL. So usually the access control lists are in something called the DACL. D is for discretionary. And the SACL, I think it's for security or secondary. I don't really remember. I never remember. And usually that SACL was used for audit tokens. So for instance, when someone opens a file, you can actually say, oh, I want to audit. Whenever someone opens that file, I want to get like an event popped up. And in Windows Vista, what really happened is that extra data was added to the SACL, and that extra data is the integrity level of the object. And again, I'm saying I gave a file as an example, but it could be really any secureable object that includes, I don't know, desktops, that includes utexes and so on. Any object in the kernel, really. So they now have another thing called integrity level, and that integrity level ranges between, well, untrusted, low, medium, medium plus, which we probably will be discussing shortly, high, and system. So these are the integrity levels in that particular order. And the idea is that you can't access higher integrity level from integrity levels that are higher from your context. So for instance, if you're running as the normal token, you would have a medium integrity level, and therefore you will not be able to write to files that have high integrity level, for instance, or system, and so on. So non-elevated is typically medium or below, and elevated is typically high. So that's basically how the thing is implemented. It's another security mechanism, because even if you have, say, read access to a file or write access to a file, you will not be able to actually touch it unless you have the right integrity level alongside the traditional ACL that Windows gives you. Next slide, please. So just out of, just to make sure that we have the same tool sets, iCackles, there was Cackles before iCackles. I think you can still use that on Windows, but iCackles can be used to view or set the integrity level. It's just the, an XZ that is always there on Windows. And default integrity level is medium. If you create a file from your context, unelevated, it will be medium. And then you can see here basically that I have a file called test.txt, and you can use -L to list the entire all of the ACs, all of the access control entries in the file. And if you look at the last line there, you'd see that it says mandatory label high integrity level. And that basically means that the integrity level for it is high, right? And if you have a medium file, you'd either have medium or you simply won't have that, which again defaults to medium. And for system, you'll see system and so on. By the way, this concept of integrity level is not only used by UAC, but also used for other things. For instance, I bet all of you are using a browser. If you look at Chrome or any other, like Edge and so on, if you look at any other browser, you'd see that it actually, like there are usually two processes, at least in a browser. One of them is a render process, and the other one is actually the one that's doing all the heavyweight risky logic. The render process, the one that doesn't have a lot of permissions, will also be running as untrusted or low integrity level. So even if you get a remote code execution to that, on a, let's say on a browser, you'd still have to run some code to basically get over that and other mechanisms, but basically that. So because you're running in a low integrity level, you'd have issues to continue your attack. And usually in browser exploitation, you'd see things like sandbox escapes or whatnot that are used as the other part of the attack, or any elevation of privilege. So that's a bit about integrity levels outside of the UAC concept. Next slide, please. For UAC, annoying window popped up, and the way the Windows Vista experience was not fun. And initially, UAC on Windows Vista was had two levels. One of them is always notify on everything, and the other one was UAC is turned off. And after Windows Vista, Microsoft introduced two other levels. One of them is the notify and the notify secure desktop, and the other one is notify no secure desktop. And they made the notify secure desktop the default setting, which we will be discussing today. One thing to note is the UI separation. The UAC window that you're familiar with actually lives in a different desktop and a different Windows Windows environment, and the way for you to interact with that is kind of almost directly, in a sense that you can't really use things like automation or auto-it or whatnot to actually input data into the UAC window. Otherwise, a UAC bypass would be very simple. Simply try to run the operation that you want, have that UAC button basically pop up, and then click yes. You can programmatically click yes because of UI separation. So keep that in mind. When I talked about integrity levels, I mentioned briefly that there is untrusted, low, medium, and then high-end system. To medium, there is also something that we sometimes call medium plus, and that medium plus is kind of like an extra bit that lets you actually do UI interaction with the UAC prompt. So that's a thing, but it's quite rare to see in real life that's being used outside of the operating system. Most UAC bypasses focus on the default setting on the notify secure desktop. It's very rare to see UAC bypasses bypassing the always notify, aka the Vista nightmare. But basically, again, on most systems, you'd have notify. Otherwise, it's really hard because you'll get pop-ups everywhere. Next slide, please. UAC is not a security boundary, is probably something that you've heard if you ever did anything with UAC bypasses, and this is currently how Microsoft sees it. It's basically it's kind of a weird thing to say, in my personal opinion, because it is a security mechanism, and bypassing it definitely bypasses something, but from Microsoft's perspective, if you're running as admin, even not elevated, as an attacker, you basically own the system, disregarding the kernel and hypervisor security boundaries, which are actually security boundaries. So Microsoft does not see UAC bypasses as security boundaries, and I've seen a lot of cases of annoyed people that submit cases to MSRC or whatnot and saying, hey, I have a UAC bypass, pay me like $1 gazillion with bounty money. And I don't think they'll ever get bounty money for UAC bypasses unless they do something really strange. Because, again, Microsoft does not see it as a security boundary. However, I did report and help them fix many of those things. And I did like a big project inside Microsoft like 5 years ago or so. And a lot of the UAC bypasses that I've seen later in the wild, I actually discovered like years ago. And one more thing that I will mention is that there is an entire UAC hardening V team that works once in a while and tries really hard to fix all of those things. They're really not prioritized because from a security standpoint, again, UAC is not a security boundary. And on the other hand, there are a lot of back compat issues. So when you fix a UAC issue from an engineering perspective, you have to make sure that you don't break anything else. So keep that in mind. From an attacker perspective, I reported quite a lot, and some of those things that I reported were actually true elevation of privilege bugs, so they were pretty bad. But most of them were fixed. And I got like funny emails like this one. I really censored the names here, but I got like a UAC student, and apparently that was an EOP, and the response was, how many times is that? 6 times crap. So pretty good. That's how I measure email responses currently. Next slide, please. So for UAC bypass classes, when I started looking at UAC bypasses, divide that into 4 classes. The first class is like a DLL hijacking kind of class. The second class is an auto-elevated process. The third class is an auto-elevated COM objects. And the fourth one is token duplication, which we probably won't touch on this time. There is an excellent, I don't remember if talk or simply like a blog post by James Farshaw from Google Project Zero about the token manipulation thing. And that's probably the only UAC bypass that I've seen that actually attacks the UAC mechanism itself, rather than some victim that basically uses something with UAC. We'll see an example soon. Next slide, please. So auto-elevated executables. Make things not Vista-like, certain processes are auto-elevated, and that means that if you run them from a non-elevated admin, right, from a medium integrity level context, they will basically run, as new processes with integrity level equals high, which means that it's auto-elevated and without any prompts, obviously. So an example is SLU. I really don't remember what like they're supposed to do. I just see them as UAC bypass opportunities at this point. And those exes must be signed by Microsoft and have a proper manifest. So you will not be able to basically forge one yourself unless you found something very interesting with the the way that Microsoft validates signatures, which will be an actual bug. And you'll manifest this auto-elevate true / auto-elevate, and that basically means that the process itself is auto-elevated, and it will be inside the content actually of the exe as a resource. So that makes an executable auto-elevated, and we'll see an example in the next slide. And the idea is that, thank you. The idea is that if you're able to make one of those auto-elevated executables run arbitrary code, you win. Why? Because they run as high IL, high integrity level, with no prompts. So, some of the ways to do it is they rely on many things if you think about it, because they still run as the current user. They just run in a high integrity level. So you can basically spoof a lot of stuff and basically poison them in hope to make them run arbitrary code. So for example, manipulating registry keys usually placed under the H key current user, you can write to them with medium integrity level, as opposed to H key current local machine, which you have to be elevated to write to. So if you're able to manipulate something in HKCU and then basically run an auto-elevated executable that relies somehow on that registry value and somehow makes arbitrary code run from that, then you win. The other thing that they rely on is environment variables. They don't clear them very well in many cases, or rely on them in some ways. So if you're able to poison an environment variable in a way that would make it run a different process than what was intended, you win. And the last one is files on disk. And DLL sideloading, for instance, was very popular as the first type of UAC bypass class historically. And there are some other ideas that you can do to those things. Now, next slide, please. So in this example, you can see I mentioned SLUI, and you can see me run strings on SLUI, and then Findster, which is the Windows version of grep, to look for auto elevate, and you'll see that it says auto elevate true. This is basically what makes the process auto elevated, alongside with the fact that it's signed by Microsoft. Next slide. This is an example of my research. It's really funny because, like, as a Microsoft employee, I could probably get access to that code, but it's sometimes easier to open IDA than actually looking at the code there. In this case, we have one process called system settings admin flows, sorry, and that process is auto elevated. It's signed. And one of the first things that it will do is basically do the following. Even if you're unfamiliar with how Windows source code looks like, on the first paragraph there, it will basically take the Windows directory, like windir environment variable, and expand that to some path. And that's basically because you can install Windows not on C Windows. It can be anywhere, right? In potential, at least. So this was to basically find another file called dsym.exe, and then build some elaborate command line that uses the dsym.exe with some other like flags to it, I guess, command line arguments to it, and then basically run that command line with create process W. So there is one issue here, and I hope you can see it, but if not, then you can basically see that in the next slide. Thank you. So this is an example. If you can manipulate this environment variable, and I know windir is a system environment variable, but the good thing is that when you call expand environment strings W, it will do that in a particular order. When it finds an environment variable like windir, it will actually try to expand that first from the user's context and then from the system's context. So normally windir only exists in the system context. So and basically is normally to see Windows, but you can basically create it to be whatever set it to be whatever you want as an attacker. And the idea is that I can poison this windir, drop a new directory called system32, drop a new executable called dsym, and then basically run this system settings admin flows. And it will basically run as high integrity level because it's auto elevated, and then spawn that new dsym process, which is a fake process, right? It's a process it's a file that I created. And I didn't mention that, but processes, when they call create process W or shell execute, they will basically run their child with the same integrity level. So that's what makes this exploit work. Next slide, please. I don't know what this black screen is, but yeah, okay. So this is basically the exploit, which is pretty funny. I bet you never saw an exploit in batch before. But what I'm doing basically is saving the old Windows directory, which is basically windir, and then I'm setting a temporary directory to be C program data, which I can write to. I basically create a new directory called system32, and then I copy this uber exe, which is, let's say, my payload, and I copy it as the temp directory system32 dsym, and then basically I set the windir environment variable to be that temporary directory. And then I run the system settings admin flows. I did need to add one command line argument to get to that code flow in system settings admin flow. That's the install internal developer mode package. I got that by reverse engineering, but that's pretty much it. That's the entire exploit. It will basically run system settings admin flows, which is auto elevated, run as high. Because of the windir environment variable, it will actually consult with the temp directory that I had there and run my fake dsym.exe, and basically I win. So that's basically a very easy UAC bypass. Next slide, please. That's another example. That's another auto-elevated COM object. And you can see here in the left side of the screen, two paragraphs. The top ones basically builds a path to an LNK file. It doesn't really matter. It depends on like the OS version, whether it's like an endpoint or a server, doesn't really matter. And then let's talk about the endpoint case and not a server case for now. And then the bottom one basically uses the shell execute EX API, which is kind of like a fancy create process with some, some sprinkles. And shell execute EX gets basically a structure called, that I like to call Schlex, but it's not the official name. And basically in this case, you can see that the important part is that it will use the same file path from before, which is the LNK file. So this entire comp manage mgmt launcher.exe will basically run computer management.lnk. If you look at the LNK, which is the, I hope you can see it, which is the right bottom part of this slide, you'll see that it's just an LNK file. It's a soft link. And the link's target is to windir system32 compmgmt.msc/s. And in this case, you have two issues. One of them is just the one that we talked about before. It's the windir thing, right? Again, but I have something better. Next slide, please. Yeah, thank you. So as you can see here, one thing that's interesting is the MSC file. When you basically open a link, it will basically try to look at the link target and run it. In this case, it runs compmgmt.msc. The MSC file, the way that files, like how does Windows know how to open, let's say, a DOC file, a document file with Word, right, with Office, and not with Notepad? How does it know that .txt files are open with Notepad and not with something else? How does it know to open JPG files with the photo editor? And the answer to that is that for every file extension, there is something called an association. And that's basically the default program that is going to run that file. Some extensions obviously do not have associations. And the cool thing, though, is that just like before with the environment variables, there are both of them are saved in the registry. One of them is the per user setting, and the other one is the global, like system global setting. So for instance, .txt by default will always be opened by Notepad, if I remember correctly, on Windows. But you run as your current user, you can basically change that association even through the UI, and it will not affect the other users in the system. The way that it works is that it's going to write basically the TXT file association in your HKCU, H key current user. And that's somewhere you can actually write to programmatically from a medium integrity level. So the idea, in short, change the MSC file association to your program and basically run this file. This file will run the LNK file. The LNK file will actually be expanded to the MSC file. And when the MSC file tries to run, it will basically run with your handler, right, with your association, and not with the system default association. And then basically you win. By the way, I think, if I remember correctly, you can't do that for an LNK file because it's handled differently by the shell. But you can do that to an MSC file. So that's just an example, and the exploit is in the next slide. Yep. So as you can see here, extremely short, 3-liner exploit for, UAC bypass at least. And all it does is the following. It basically takes, the first one basically is just me being lazy. But basically, the only thing that, like, the juice of the story is the second line, where it will basically add to the HKey current user software classes MSC file shell open command. That's basically the file association for an MSC file. It will add the registry value of the evil executable that I want to run. And then basically I run the mgmt launcher.exe. That's the auto-elevated executable that had the issue that we saw 2 slides ago. So that's the entire exploit. Pretty simple, I think. Next slide. That's another example. This one is already well known, I think. fodhelper.exe. Again, I do not remember what those executables are supposed to do. I only remember that this one is auto-elevated. And what it does basically, it's a very simple executable. If you reverse engineer it, you'll see that, again, it calls shell execute with open. And this time it has a special file association because it's not a file. It will basically spawn the command ms-settings optional features, and that's called a URL association. If you use shell execute, and instead of a file in the LP file member, you give it HTTP, I don't know, some website, www.microsoft.com, and you run it, it will actually succeed, and it will open your browser, and your default browser, by the way. And the way that it knows to do this is because, just like for file associations, there are actually URL associations. So the schema of HTTP, the program that actually knows how to handle this schema is your default browser, which will probably be Edge or Firefox or Chrome or whatever. And interestingly, Microsoft uses that, and not just Microsoft, Apple does it for macOS and so on. They use that extensively for other purposes. So just like you have the HTTP or HTTPS schema for browsers, or FTP schema for other things, for FTP and so on, or mail to schema, by the way, for your default mail client, Microsoft uses its own internal, I might add, schema. In this case, the schema is ms-settings. And this is supposed to open your setting widget, I guess. But you can override that, because just like the file association, the URL association is also can be overridden by the per user URL association. In this case, it's a bit more tricky, because there is actually some hash that kind of is supposed to somehow protect it, but it's really trivial to bypass it. And this is like a known UAC bypass at this point, but again, I kind of uncovered that like 6 years ago when it was not known internally. Next slide, please. Yeah, this just talks about the MS settings protocol association or URL association, and you can override that in the registry with HKCU. Next slide. And this is the entire exploit. It's a bit longer than before, but basically what it does, and I know this is batch. You've never seen an exploit in batch, and I'm sorry if you guys are vomiting a bit in your chairs. But basically that's what I did back then. And what I ended up doing is overriding the MS settings URL association. The association for MS settings, basically, what I ended up doing is you can copy a thing called user choice. That's basically where it saves. It saves kind of like a weird hash there. It's called prog ID, and you can see here in the code that prog ID, basically, I don't know what it's supposed to serve, but basically it's like kind of a hash, and it kind of prevented me for 5 seconds of exploiting this issue. But basically, you can just copy it from the HKLM one, and it would work well, and you can do that programmatically. And I think public exploits for fodhelper use something different. I don't remember exactly what, but they do something quite similar. And the idea is that, again, I can just override the, in this case, what I do is I get the prog ID, and then I override the prog ID instead of the hash that I mentioned. So it's pretty easy. And again, the only thing that I do is write to the registry my executable to be the handler of MS settings. That's basically it in a nutshell. So pretty easy, I think. And as you could see, not a lot of reverse engineering is required. You could do that like by yourself. Just look for auto-elevated executables with the auto-elevate true manifest in them, and open like your favorite reversing tool and try to look for create process or load library or shell execute and stuff like that. And you will probably find some stuff. Statistically less than before, but still there are still loose ends there. I'm pretty sure. Next slide, please. Auto-elevated COM objects. This does require more reverse engineering than before. It's not just opening an executable, and reverse engineering COM is a freaking nightmare, to be honest. But you can do it. Anyone can do it. It's just a matter of time plus IDA license plus keyboard probably. You can use Ghidra probably as well. Soft ice if you're really old. So a bit about COM. COM basically is a technology that empowers developers to rely on interfaces. So basically it's quite a substantial Windows technology, to be honest. It's used everywhere. And the idea is that instead of, let's say, other systems, or even before COM was so widely used, you'd have something that's referred to, I think on Wikipedia, as DLL hell. And the idea is that it's extremely hard to maintain several versions of DLLs, right? And basically libraries. And you can see that on Linux as well, for instance. Like even libc is called libc.so.6, for instance, like on most systems these days. So maintaining that kind of versioning is kind of problematic. And instead, what COM does, and COM is not a new idea, by the way. I think it was, it was created by after learning about a different project called Cobra, if I remember correctly. The concept is really similar, and the idea is that you rely on interface. You have a COM client and a COM server. The COM server has to implement one interface called IUnknown. That IUnknown basically is, it's like the basic interface where you can ask, hey, do you implement other interfaces? I don't want to talk too much about COM. We can do an entire lecture just on that. But the idea is that you can basically talk to COM objects and get information about them. For instance, if you've ever done red teaming work, and you want to spy on someone on someone's emails, you can actually create a COM object to talk to their Outlook application. Outlook actually implements a COM server, and then you can ask certain questions like, give me all the mails from the last 10 days or whatnot, and basically get that through COM. So COM is also pretty interesting because it can also be used as with IPC, with inter-process communication. What I'm getting at is that COM can be used either in proc, and if it's in proc, you basically load the DLL to your address space, or the process loads the DLL to the address space and basically starts asking questions like, give me the interface for talking to Outlook, right? And then it could also be out of proc. Out of proc basically means that it's like the COM server is not going to be a DLL that's loaded into your address space. It's going to be in a different process, and then communicating over COM with it will be by using inter-process communications. The cool thing though is that everything is done seamlessly. So you as a developer, you don't really need to know whether the COM process is in proc or out of proc in like 99% of the time. And that's a long description of COM. And the interesting news is that certain COM objects do privileged things, right? And this was actually the crux of the user experience in Vista, because there were a lot of COM objects that were using a lot of things, and there was a lot of UAC windows popping up Vista, and that's mostly because of COM objects. So COM objects do a lot of privileged things, so it was decided that it makes sense to have auto-elevated COM objects. Just like the auto-elevated executables, you now have a set of auto-elevated COM objects. And basically, if you run as a medium integrity level and you want to talk to a COM object that has to run auto-elevated, it will not be able to run in proc because it will use your token, which is medium. So you will always be talking to the auto-elevated object out of proc with inter-process communications. Well, you might ask, where will this service run? Where will this like com object DLL be running and loaded to? And the answer is that there is a specific exe that will spawn. And you might see that right now, if you have a Windows machine, you might see a couple of DLL host.exe that are running. And these DLL host.exe are basically hosting their processes that will mostly run as high integrity level or system even. And there will be hosting a DLL, the com DLL, that will serve whatever request it gets. So you have a privileged DLL host.exe that gets inter-process communication requests from the client and does things on its behalf. And obviously, that's kind of like a target, right? By the way, you can run privileged COM objects that are not auto-elevated. It will start a DLL host just like before, but they will spawn a UAC prompt before, so they can't be used for UAC bypasses at least. Next slide, please. So that's an example. And in this case, it took me a lot of reverse engineering to do that. So I actually had to, so I ended up writing like pseudocode here. But basically, I found one auto-elevated COM object, CLSID elevated shell link. And again, I don't remember, I really don't remember what the original functionality is in many cases, but I do remember that this was auto-elevated. And one of the functionalities, the methods that it actually exposes and gets requests to is this thing. It's called create new link, and it will basically get a structure called create link data, which is not very interesting, but it basically has some data about the new link to create there, and the different object of new shortcut hook, which I never used. And the first line, like the code was really long, but in the first line almost, basically had the following thing. If the flags of this input, which is hacker controlled, PCLD, which was the create link data, if the flags basically had a flag called WD flag copy link, then a new link is not being created. Actually, just Windows will call copy file, and it will copy file based on 2 arguments that I give it. And if you see the false there, false there basically means that it's okay to override the file as well. So if you think about it, this is extremely powerful because you have an auto-elevated COM object that gets arbitrary 2 files, and like source path and dest path. It will basically copy the file and override the destination path without any verification. And this was the UAC bypass that caused the crap email that you saw earlier in the, I guess, second or third slide. And if you understand it really well, you'd also understand that this is an actual elevation of privilege. It's stronger than a simple UAC bypass. But what I'm trying to say is that reversing COM kind of sucks. But if you find something like this can be pretty good because it's a pretty strong thing to do. Obviously, overriding an arbitrary file. Windows is pretty powerful. You can get to like code execution in no time. A few examples could be overriding a service and then rebooting, overriding PowerShell profile, overriding executables that are supposed to be legitimate, and so on. You can override whatever you want, get arbitrary code execution really easily. So arbitrary file override as an exploit is a pretty powerful thing to have in any operating system. So that's the thing that I reported. It was already fixed. I don't remember if this was ever public, but it was fixed at least for sure. Next slide, please. Yeah, and this is basically an arbitrary file override, as I mentioned. Next slide. And override a Windows service image. Yeah, that's the thing that I ended up doing, I think, just for demonstration. Thank you. Auto-elevated tasks. I think I saw that abused like twice. Some Windows schedule tasks might run with high privileges. You can see that actually in the task scheduler, there is a flag that says run with the highest privileges or something. And this basically means that it will run auto-elevated and with no UAC prompts. So abusing those tasks can be good. Some of those tasks might also be triggered from a weak user. So triggering the task is also a problem. And basically they suffer from the same issue as auto-elevated components, logical bugs. And some of them depend on the target environment. Next slide, please. This is an example. This was actually in some production environment, so I censored the things a bit. But this is me running PowerShell, so I got better than batch this time. And in this case, you can see that I'm getting a scheduled task. I censored the task name, but you can see it says run level highest. That's the thing that I mentioned. It's basically going to be auto-elevated, and then the actions. For every scheduled task on Windows, you have a set of actions. Usually there is one really, and in this case, it will basically run PowerShell, as you can see, with the command line that says Windows style hidden, non-interactive, whatever, and then it will run something from program files. So this looks, I mean, interesting, but what can you really do with that? All it does is to run PowerShell. And I will show it to you in the next slide. Yeah. So I'm going to focus on PowerShell and also CMD, if you ever see CMD being spawned. Running elevated PowerShell without the no profile flag might break UAC if you think about it. Why? Because when PowerShell starts, it will first load a thing called the PowerShell profile. And basically, it's almost like a bash RC for PowerShell, and you basically write whatever you want there. Profiles are stored in a writable directory from a medium integrity level, so you can basically abuse it with a one-liner. Echo evil.exe to $profile will basically make whenever PowerShell runs, make it run evil.exe, and unless it -no profile flag. And that's kind of like a problem that will probably always persist, because the main issue, if you think about it, and that was the main issue with the HKCU thing and with the environment variable poisoning, the main issue is that the token is split, but the user is still the same user. So so you still run as high, but still as the same user, and the profile path on the disk is still accessible to you through medium integrity level. So you can do that, and that's pretty much like the entire exploit that I had for that auto-elevated task in this case. Do the same for CMD. If you're ever able to trigger a CMD that will run auto-elevated, if it does not have the /d flag, you can do something similar. On CMD, you have this path right here. I hope I'm not. I hope everyone can see it. Called autorun, and that's again like a bash RC, but this time for CMD. So again, pretty powerful. Does the same thing that PowerShell does with the profile. Less sophisticated, but still pretty cool. Next slide, please. So that was just a couple of examples. I have more, but I think that's like you've been well fed, I think. If you think for defenders, if you're ever looking for UAC bypasses, the first thing that I usually do is to look for popular environment variables that should never be changed, like WinDir, system root, and so on. These things are like they're supposed to be carved in stone, and there is no reason for the user to change that, be different than the system. Actually, it will probably break the system if you don't revert them in your exploit. So be careful. Another thing to do is to look, I didn't talk about DLL sideloading at all, but trust me, there are tons of them. And this is where all the Process Explorer hackers come into play, and basically look for, an auto-elevated executable, let's say, that tries to load a DLL from a writable directory and just gets a file not found or something. So planting that DLL probably can get you to a UAC bypass. So for defenders looking for DLLs, usually with common Windows names, like, I don't know, apphelp.dll and stuff like that, that are out of their normal directory is something that I would do. Look for suspicious activity by a high integrity DLL host. Is another thing that I would do. I know it's pretty vague to say, but in some cases you might actually be able to do that. Look for suspicious file or URL association modifications. There are certain files that you expect to see association modifications for, like TXT. You should never see someone trying to modify the program handling .msc, I don't know, exe or lnk or com or whatever. Those things should never change. So keep that in mind. Same thing with URL associations. Reality, no one should change any URL association that starts with ms- probably. And there are public resources. I think the best resource for public UAC bypasses is UACme on GitHub. It's actually being maintained quite well. And I've been following that for like the last 5 years. I have some more UAC bypasses that are not disclosed there, but I'm trying to basically not make it easier for attackers. So I'm not publishing any of those, and I'm working really slowly but really carefully with the Windows team to have all of them fixed. And in fact, some of the mitigations that were added make it harder or try to kill an entire bug classes. So for example, whenever an auto-elevated exe starts expanding environment variables, I actually forced all of their developers to start to expand environment variables only from the system context and not from the user context. And that should really help out in some cases, again, to kill like an entire bug class. Unfortunately, there are still some issues with the more sophisticated bug classes. Mostly auto-elevated COM objects are usually the ones that are very hard because it's a case-by-case basis. Next slide, please. Yeah, and I think that's pretty much it. I think I'm really time. If you have any questions about those things, like feel free to DM me or whatnot, or just reach out later. And I am open to public questions if there are any, and if not, then thank you for having me. So looks like there are no questions. Silence is agreement. Thank you again. I'm dropping the mic.
Thank you, JBO. Or I'm not sure how to. You realize you've just ruined a week for me. I'm going to be playing around with this, so thanks. This is an excellent presentation. This is going to be a lot of fun. I want to try this on a CTF to see if I can raise elevations on a Windows box. That would be fun. So thank you. That's our last presentation for this evening. However, the space is open until 8 tomorrow morning.